Well, Ivan, I read a blog article of yours recently. You had, I don't know, three or four different things to say about how databases and, let's kind of generalize is the wrong word, but let's call it thinking about SQL and what that represents, kind
Yeah,
of the storefront of data, how that should fit into making AI useful, right? And how these two things, I think you use the metaphor how they should be peanut butter and jelly.
yeah,
Make a delicious thing. We'll figure out what the marshmallows you put in there is to
sure.
make it a delectable food. But like I think as when I was reading that, I thought it'd be great to delve into it more,
Yeah,
as the AI would say. But I'm curious. Like I don't read a lot of things that talks about how all of the data in the world, like especially all the enterprise data, like actually hooks up to AI stuff. Except that like you've got to put it in a vector database, and I can't imagine we have enough time left in our short lives to convert everything over to a vector database. I don't know. Maybe it's fast
well,
enough, but like, but tell me like
yeah.
if we're gonna have all this agentic AI stuff and just normal AI stuff, how are we gonna hook it up to databases? All the stuff that we have and that works really well.
Sure. Well, so let me throw my opinions out there. And the first thing I wanted to mention is about the vector database, right? So the vectors are really a way to deal with your unstructured data. So your images, your video, your audio, and even certain things like PDF documents. Because what the vector is a mathematical representation of what's in that thing. So if you wanted to take a picture of a cat and you pass it through the right AI, out comes a series of zeros and ones, a vector, which represents the meaning of what is that cat, right? But for other data, for example, like if I wanted to look at shipping records of what parcel was shipped. Let's say I'm a shipping company. I want to store shipping records or bank account data or transactional data in general or customer profile, customer history, what we call structured data. That you really don't vectorize. That already is in a format that is easy to query and store in a database. So this idea now is we've expanded what's in the database from essentially your structured data. Now it can also store in vector format all your unstructured data, which just makes the database richer, right? So the first thing I would just call out is we're not going to go vectorize all the data. We're going to vectorize all the unstructured data, the videos, the images, the drone footage. And you know what? I think we will vectorize it all. It's just going to be a data pipeline. So anybody who's collecting data, as you collect it, you're going to vectorize it and store it in that format. So yeah, we may actually just vectorize all that unstructured data in the world as well.
Tell me if I've connected this stuff together wrong. But the other thing that seems different, if we had vectorized and more structured data, is if you hand over vector stuff to an AI, it's not as precise as if you like exactly sent like an SQL query to something. Like it's still going to kind of like search around for like, what the correct magic mathematical thing is, or at least what it thinks the correct thing is.
It comes down to the nature of the data, right? So again, let me use my classic favorite example, which will be I'm doing a data management project for the Port of Los Angeles, right? And as the Port of Los Angeles, I have records of what ship went from A to B, right? And that'll be like literally there'll be a ship number. So this is exact data. I'm also going to have camera footage. Let's say I have drone footage of the port. And if I want to search for, I put in a search for within the drone footage, what will be my search term I'm looking for? Maybe I'm looking for a bigger boat than normal. So by very nature of looking for a bigger boat than normal in drone footage, it's not exact. That's where you get to that fishing around in the data.
Right.
So it's before we even get to the vector versus non-vector, the point is what is the data and what type of search you're doing. If you're searching for an exact ship ID on an exact date, it will be the database can exactly find that. If you're shipping for some description of a video, it's going to be hunting and pecking, but based on the semantic meaning of what's in that drone footage.
it's kind of two types of data, but also two things you want to do with it. And one of them, like you're saying, is you want meaning. You're like trying to figure out what the semantics, what this thing means. And the other one, like your shipping records, is like a shipping record has meaning, but you just want to know state. Like this thing happened or this thing is. Like there's not really, pun intended, I guess, meaningful meaning behind like, the cord is in the container.
Right. like it's a specific data point. To level set, I think the concept would be still to the advantage of taking all that drone footage and combining it with the shipping records in a database is that now it's almost like you're a person who had eyes and ears and you've added another sense, right? You've got another way to get input from the world. Or let's take a second example just to visualize again. If I'm managing an industrial farm with thousands of acres, right? We may know what we sprayed where and when and what crops we planted where and when. But if you have, again, drone footage that's capturing, the hue of the green of the plant in all over there, right? Then that's another, you're enriching your senses and integrating it into a database that can be accessed and combined and queried really to answer questions.
So we've got these two distinctions of the types of data and also the things you're going to do with it, right? Whether it's hue of grass or size of ship or whatever. And so like how are you thinking that then fits in to like writing some kind of AI application? Like what are the integration points and where do these things, how do they actually talk with each other? That's a weird way of putting it, but how does it integrate together?
Well, I think the point is, as a developer or as a information architect, who the amount of data is so large that we need to prepare in advance by doing data cleaning, data integration, and data collection, and data preparation, right? So, because there's too much data to just throw it all in as they call in a lake, right? Or to throw it all in like, think of your closet that's just a mess. All the stuff's on the floor, right? Everything, if you prepare everything, and because it's so much data, by preparing everything in buckets and shelves, when somebody's going to come look for something, there's a good chance it's going to be efficient. So the first step is we've got to prepare everything in the database. And then once it's there, then your various agentic applications or non-agentic applications or anybody who's trying to access it, we set up these access patterns. What is going to be the typical, you optimize for what types of accesses do we think we're going to have? And then how do we structure that data almost physically on the computer hardware? Like, how do we organize the blocks and the search paths so that the type of questions people are going to ask are most likely going to be solved in the mathematically optimized time frame? And so then once you expose that and provide an interface around that data, you expose that interface to the next level, to an AI. Even let's start just exposing it to a traditional, not traditional, but a modern AI model. If they know how do I access this data, then it can use some on-the-fly intuition and say, oh, I've got these 5 data sets, I access them these ways, let me generate a query and go get what I need. And that could be an app or it could be a person talking to an LLM.
The first part of connecting these things together is basically, I guess what you would call in the AI world, having a tool, right? And having a tool-aware AI thing, which, nowadays there's like model context protocol and very thrilling, exciting stuff.
So the model context protocol, right, has become the new API front end to the data sets that AIs expect to use. So I don't think it's super fancy. It's just a well-defined protocol of how AIs are going to reach out to data. And you mentioned the word tool. I think tool is the key framework by where you expose essentially APIs. You create a tool, which is like an API that says, if you want to do this, come in through this tool, Mr. Mrs. AI.
I'm pretty sure you said this. But are we talking about having like we could say the model, the AI, whatever, but having the AI generate the SQL that it executes? Like what? That's an interesting going from open-ended AI stuff to very structured things. How does that play out?
So the question is once you have a vast set of data available and you're exposing it to an AI, you're going to write a tool. And the tool is going to be this model context protocol tool that an AI knows how to say, okay, this is what it is, this is what it gives me. But what will that tool actually do under the hood? And then I think that brings us back to the article. It is to say, okay, if the AI is going to ask me a question, what will be the most efficient way for me to bring back the AI the answer? And when I say efficient, it just comes back to speed and money, right? How do I spend the least time and the least money? Because if I'm doing millions of queries, obviously people want speed, but secondarily, if it costs 10 cents per query versus 1 cent per query of compute and physical resource and energy, right? Then at scale, it could be millions or billions of dollars of savings if it's done most efficiently. So it's important not to just throw the data on the floor and then have a tool that says, hey, AI, just ask me what you want. And I'll just go looking on the floor, picking up like, hey, is this rock the thing they're looking for? Is this shoe in my closet? No. We want to, and that brings back to the article, which is that the value that was created in SQL. SQL is the language that is designed to have a query interface to data, but underneath SQL is the practice of query optimization. So query optimization is a mathematical study that's done in computer science programs that says, what are the algorithms and paths to most efficiently answer a question, essentially? And so the hypothesis is that SQL will be even more than ever the centerpiece of how a AI will go fetch what it's looking for, because other paths are just going to be less efficient.
That's something that also was interesting in your peanut butter and jelly data sandwich, is the point that you were just making, is that we have, I forget whenever the paper was written, it was the late 60s, like whenever sort of SQL launched, and so what would that be? 50 years? There's like 4 or 5 decades of optimizing it and making it like the best way to get to data. And also, from what you're saying, I'm also thinking it originates when there was much more expensive compute.
Yeah.
And so like it really mattered a great degree back then. And so that is, and you're looking around, the mess on the floor is a good way of putting it right there. It seems like if you have these huge, never mind lakes, but like oceans of data, you also need some way for the AI to like know when it should query this data, right? And know like how to build these queries up and what it looks like.
So it was EFCOD. EFCOD was known as the originator of relational databases, and I think it was the late 60s, early 70s. And I don't know if he was directly connected or later it got picked up by IBM Research Labs, right? And IBM was the first mover on commercial databases, and then Oracle came in, but it was all based on EFCOD's mental model that he published, and many other types of database systems were tried before that, but the SQL and the relational database really succeeded over the last 50 years, and really it is because what SQL and relational database does is construct a language and a process to basically, when the user asks a question, calculate every possible way to get access to that data, and then to find the lowest cost solution and then go and execute that and bring back the data. And so if you didn't do that, then what the AI is going to essentially do is try and replicate that on the fly. So if I have 1 million lines of source code that's been finely tested to optimize access to data, what the AI would have to do if they didn't have that would be essentially regenerate those calculations every time someone asked a question on the fly. And it's just not going to, it just doesn't work, right? Like, so you'll find the data, but like, if it hasn't been structured, organized, and optimized, it just could take thousands of times longer.
let's go back a little bit. So I think the tool part is more or less taken care of, right? You can hook up whatever it may be in the future. You can hook up an MCP tool, an MCP server to an AI, and you can tell it like, hey, you've got this database available. It has this structure to it.
Yeah.
Figure out when you need to use it. Like there's always a little bit of mystery to an MCP server, because at some point you're just trusting the AI to figure it out, but it generally does it. So at that point,
the part they're figuring out is the part the human would have figured out too.
right, exactly. And so you have the tool hooked up, and I presume you give it like the table structure, or like what
Yeah.
what do you educate the AI on?
So the tools are, again, a new word for APIs, right? For interfaces, right? And so what interfaces do we expose through our data MCP? The first thing you're going to expose is your data catalog. What data sets do I have? And the data catalog in the ideal world is going to be a rich and annotated data catalog that not only stores the list of tables and, the list of columns, but stores like background information about the data. Where was the data sourced from? Who updated the data? Was it updated by a system? Is it dynamically updated? So all the information about the data, which they call the metadata, right, would be in this data catalog. And so I think the first thing we want to do is have a very rich and robust data catalog that is exposed as a tool, and that there's these different interfaces, like list me all the data sets. And then within a data set, list me properties of that data set. Because if you know, for example, the names of all the data sets, and something sounds like farming or shipping, I may want to look more into that. But then I could then call the tool and say, tell me about that data. And that tool would then come and say, okay, here's the history of this table. Here's where it came from. Here's the source systems. Here's the lineage of the data. Here's the rows and the types of columns it has, right? The data types. Then the thing can think about and say, do I want this or not? At all this point, they're not really even figuring out how to efficiently write a query. They're still figuring out what types of thing in general they want to do to solve their problem, right? What kind of resources are available?
Just what's available. Exactly. Yeah. That's interesting, because it mirrors like the tool programming I've done. Like, it's turned out that going back to that word, the meaning, the semantics, the documentation, or the metadata is really, it's hard to say that if it's the most important, but it's definitely, if it's not good, it doesn't work.
It's a starting point. Yeah.
Right. Like, and I would imagine with a lot of data sets that are out there, you don't want to just go off the name of, for example, in a relational database, the column name. Yeah. Right. Like, you might want some extra information that you would give a human, that you would give an AI to understand what's here and what to do with it.
So the database systems, the commercial database system industry, kept the metadata, or the information about the database, very lean. It was never built as a journaling or annotation to describe context about the data. It was like just the facts, right? I got this table, here's the name of the column, here's the name of the table, and then go look at the data. You need to know what's in it. You need to understand how to interpret that, right? And so an entire additional layer of data cataloging was created in the industry to say, no, I want much more background and context. And basically the metadata is yet another database, which just stores data about data, right?
Right.
But exposing that first opens up the AI to do intelligent things, right? And to say, okay, I know what the problem I'm trying to solve is. Let me see what resources I have.
Yeah. So that's kind of the first layer, or the first phase that you have, like with your shipping example.
Yeah.
You've got a metadata database, so to speak, that's like, here's all the information we know about whatever it is, shipping logs, container placement. I don't know what's in port databases, but so the AI goes in and discovers all of this. It basically understands and learns what's available to it. And then like what's the next cluster of things that happen?
The thing I would say before even going to the next bit is the way that tool will be implemented is going to be all that metadata will be stored again in a SQL database.
Right.
And when the tool is fired or triggered saying, tell me this information, it's going to write a SQL query, right? Because SQL query will be the most efficient way to fetch the metadata, right? So I'm just throwing out there that there's yet another case where SQL is immediately in the loop before you even start getting to the data. Because the metadata itself, the most efficient way to store it and query it will be in a SQL database. Then after that, it kind of formulates, okay, I've got 7 tables. And these 7 tables, let's say shipping records, drone footage, product information, weather information. And by the way, I need to join these data sets on these 5 keys, right? And so how am I going to go match up this data and bring back the proper data set? So it's going to have to generate some sort of a kind of physical representation saying exactly what it wants to get. Let's say I have 10,000 hard disks or SSDs that the data is spread across. So everything I want to access, it's somewhere within 10,000 SSDs. And obviously those 10,000 SSDs are put in various computers, which are on a network, and they're not all in the same place. So it says, this is what I want. And out of that data, basically I want 1% of 1% of that returned in a certain structure, right? So now how do I go get that 1% of 1% without just saying, give me every piece of data from 10,000 SSDs and then check, is that what I want? Is that what I want? Because that could take literally years.
Right.
That's where the query comes in, the SQL query, and having a system that knows how to say, oh, that piece of data will link to on disk 77 links to the data on disk 82, and it's on sector 44 and it's on sector 83 there. How do I go and fetch and match and compare and then bring back the ones that work and then just eliminate everything else, right? And so that's where the SQL comes in to say the AI just doesn't have to think about where the data is on the disk. It doesn't have to think about where it lives physically. It can use the model. The model is the relational model, tables and rows, and then express it that way, and then leave it to the database to find the most effective way to go on and locate it in the physical device.
Yeah, I mean, in my mind, the way I think about that is the AI. Well, one thing, since SQL is so old, that is mature and proven and ubiquitous.
Yeah.
Like if I encounter this a lot when I'm, whenever you do programming stuff or you do other things, I'm always looking for domains that I work on in an AI where there is a lot published on the public internet, right? Because that's like the raw thing that an AI is trained on. And when it comes to SQL, maybe there's not as much SQL as there is Java out there, but maybe there is that you just would come across in training it. So, which is all to say, how to do SQL is extremely well understood by like humans and AIs and stuff. So which leads to the next thing that kind of, as you're saying, like all the AI has to do is know how to ask a question, not know how to like do the actual work.
So separating the data model from the physical access of the
exactly.
So I mean, what if you didn't have SQL at all? If we didn't have a database, let's just bring it to the basic point. Let's say you're a computer science, you're building a system from scratch as a first-year computer science student. The first thing I would do is I would just create data files. Let's say .csv. Right?
Yeah.
I would just put the data in it, right? And if I have a lot of data, like we said, then I would have, let's say, I'd have like 10,000 files on each computer, and each file would be like a terabyte of CSV, and then I'd have 1,000 computers filled with files, right? But there'd be no like index or no way to quickly find anything. So anybody looking for anything, you'd have to open up all the files,
the entire thing,
and then just start scanning them and saying, okay, what's this row? What's this row? What am I trying to do? And any query you'd want to ask, you'd have to scan every single file, every single row, analyze it, and then say, what do I do with this in my context? That would be the most inefficient possible way.
Madness. Yeah, exactly. Yeah. And so that, I mean, I think, is that kind of where you end up? Like, you're working there with AI. It knows how to generate the SQL. It understands the meaning from from the metadata that you had? I mean, I guess you run it, and then there's a response for it to deal with or benefit from. Kind of what happens after that?
Well, I mean, then you would iterate. They could iterate and try something else. But I think it's one complete loop. When one complete loop of the process would be the human user has some sort of objective. It indicates that objective to the AI. It may not be just a human user. To your point, it might be an agentic application that's been pre-programmed with a goal. But somewhere, a human is assigned a goal,
right?
An outcome to the AI, like make my picture fancier, or whatever that outcome is, right? It has to be given by the prompt, right? Then the AI has its goal in mind. It's going to use the metadata to locate what resources it has, and then it's going to generate a query, execute the query, get back the data, and that would produce like one loop, I think, in the process. It could then try again or do other things. But
you and the Tanzu data team, they spend a lot of time on like enterprise data concerns, right? Which are there's many more of them beyond just what we went over there. And like, how do you imagine the kind of management and optimization, like how does that fit into this? Like, because it seems like the AI isn't going to do any of that for you, but it's still something that you need to worry about.
I think there's going to be a few layers and a process, right? So as we said in the beginning, because of the size of the data and the amount of compute resources at play, this has to be done very carefully to not waste money. And money is an equivalent for resources, right? Human resources, energy, computers, right? So it has, and in order to do all this very efficiently, step one is data ingestion and data pipelines, right? And so thinking in advance, planning in advance as a data architect, we're going to build our data pipelines that integrate and bring together as much different data resources as we have that we think are relevant and prepare them in the most efficient structures, let's say in databases and the right schemas, to be ready to be used. But then there's going to be another layers, right? Because for both speed and protection, I think what's going to happen is we're going to carve out subsets of data into smaller databases, perhaps, and have, again, data pipelines from the big data system into these, have a pipeline. So everything's flowing in, let's say the drone footage, the shipping records. There could be other industry examples that have more data coming in faster, let's say biometric data if you're doing some other thing. But in any case, as the data is flowing in, my key point is it would be efficiently stored and structured, but also lifted again into other layers. And these other layers produce essentially subsets of data in perhaps a different implementation of a database. So there's about 100 or 200 different database solutions, open source and commercial, on the market. They all, let's say, do SQL or some sort of querying, but they have very different flavors of metrics of their speed and their profile. And so, for example, you could compare a Hadoop system with a MySQL system. So you might want to store a whole bunch of stuff in a Hadoop system and a whole bunch of less stuff in a MySQL. If you know, I've got a very high value application that will very efficiently access data through MySQL, right? Then that would be like another layer. And that layer, once that AI is talking to that layer, they're never going to get, no matter what security put in place, they're never going to get to the actual bigger data set, which may have more valuable information that you don't want it to have access to. So I think there's a pipeline, and this pipeline is going to be running 24/7 and going to be updated by people probably who are designing, not AIs, but people are designing this architecture, and they're going to be updating these pipelines. It'll never be down. It'll always be kind of online upgraded. And then new layers get created, new APIs get exposed, and new subsets of data get exposed to different AI applications. But some AI applications you might want to give, if they're very well carefully securitized, you might want to give them access to really much bigger data sets that span huge layers.
It's interesting. Like, I don't know how data architects phrase this stuff, but what you're describing is you've got well, whatever, in my language. In my mind, what you're describing is you've got a new persona of who's consuming the data. And that's these various AI things. And the way that they want to access the data might be different than the way that, like, the night manager at the shipping yard wants to access it. And so that requires, obviously, you can be AI assisted to do whatever, depending on how good it is in the domain you're working in. But it shows that need to do a lot of data architecting and ongoing do it. Like as the AI does something new and evolve, you're always still sitting there thinking about, I mean, I'm repeating what you're saying, but how have I arranged the data? How do I need the whole data set or a small one? Like, how do I set it up to be accessed?
And that's where Tanzu's philosophy really kicks in. So Tanzu has a mental model called DOO, develop, operate, and optimize. Right. And so when you think about from a data perspective, what that means, develop. Develop, I start with the metadata catalog. People, even a person who's architecting this thing, how are they going to understand all the resources? So the developer can access the metadata catalog, interact with it through LLM assistants, and start asking questions. Like, if I want to build an application like this, what data sets do we have in our enterprise? What is the history of that data set? What will be the most effective thing I can combine to solve this application problem? So the developer is empowered through metadata and through coding assistance and through AI to help them develop their system. Operate, meaning that how do you create these pipelines? And how do you create the efficient SQL querying? And how do you create the flow of data from layer to layer to layer, the transformation? And then you said optimize, right? So then now this is all running, but things have changed, right? And maybe I'm storing certain data sets let's say I'm storing data sets in iceberg. Iceberg is an open table format, very popular. But then as I'm optimizing it, I say, wait a minute, this is being accessed 1 million times a day under this pattern. We could be saving energy and money if we took it and cached it out of, for example, iceberg and put it in Greenplum, because it's going to use 10% of the energy and compute resources to access it through Greenplum than through iceberg. So then let's recommend that, and let's optimize the platform, that it's a live system. We're going to change the architecture, right? So develop, operate, and optimize creates this framework for a 24/7 ongoing smart system that you can build applications on.
I think I haven't really thought a lot about the role of the like data architect and database in an AI world. Everyone's freaked out about the application developer and if they're going to be replaced and all that stuff. But I haven't come across a lot of data stuff. So that's interesting to think of. And I think, so given that there's, I don't know, potentially a lot of change going on, or just at least a new fun technology to be useful. We'll see what degree of revolution it is. But the last big data thing I remember, at least, was like maybe the last exciting one, maybe they're very good but boring ones, was the whole like NoSQL thing, where it was just like, it's right there in the name. Let's not have SQL. And like what like you live much more closely through that than I did. Like, what do you think we can learn from that wave of things that we can apply to this new way of working with and kind of dealing with data?
So I think the NoSQL systems, at the end, they don't use SQL, but they do have a way to query them. They do have access patterns, right? And I think it's slightly unfortunate that all of the systems that are not SQL got collated as one
right
technology called not SQL, but they involve some different interfaces which are useful. So there's a key value store, right? You could say, here's my key, find my value. You can't write a big SQL query. You just say key value. There's another one that's been fairly successful and popular is this document kind of a database where you're basically, let's say, storing JSON documents, and then you're looking for kind of matching JSON documents. And I think those systems were good for developers who could say, I don't even need SQL. And I think SQL was kind of everything in it for everyone before that. and there was a bit of a backlash that it was overused. So there were times when I just need a quick thing. Let me just find that quick thing and bring it back, right? Or I'm just right. So
Right.
it became a bit of a backlash against, and SQL is non-trivial once you get complicated. You could have a 8,000 line SQL query with 32 joins, and then people look at it and they're like, what the heck is it doing? The good part about this is that actually AIs are quite good at reading 5,000 line SQL queries. But so I think the point is when you look at the caching layer or the application layer, when you have an AI or an application, let's say I have an application and I know I've got, let's say I have 50,000 types of data and it's stored again across this huge environment, but I know that I've got a certain access pattern where all they're going to do is be looking for JSON documents over and over and over again under a certain pattern. Then what I want to do is create that pipeline that carves out the data from the huge SQL database and puts a subset of the data in a JSON document database. And then that'll be the most efficient access pattern for that application or use case. So at the core, I think the big heart of everything, you're going to want to have a SQL interface into all the data. But then for specific caching layers and application layers, we may carve up consumption databases, and they're going to be put in the most relevant DB engine for the access pattern. So again, there's hundreds of DB engines. So you might want to use a MongoDB as an access pattern if that's the perfect access pattern for that application. And that could be part of the optimize, right? As part of the optimize, you look back and say, hey, this is being accessed through SQL, but it could be a key value lookup. And if we put it in a key value lookup, we could be doing 10x more transactions per second with less hardware. So I think NoSQL still has its role, right? Probably more on the consumption layer where you've got applications that have very targeted use cases and the data set's well known and it fits into some pattern, then you do that. But my hypothesis back to the article is that the big data set still being able to write expressive SQL is the mathematically most effective way to expose it all. But then sub-layers we can expose through applications and through specialized databases that might have very nuanced access patterns that are better in another system.
And then also, like you were saying, for people who are on that gradient of disliking SQL or finding it not delightful enough to get over its incomprehensibility.
Yeah.
When you get to thousands of lines, on the other hand, you've got your little AI friend who's perfectly happy to go through the thousands of lines, which it adds, so to speak, to the additive nature of what you're saying, right? Where it's not so much that you have NoSQL to only have NoSQL, only NoSQL. It's more that you figure out the access patterns and the things that are good for doing it that way. And as you were saying, I mean, I do remember this from NoSQL. It seems like the ultimate thing that NoSQL was good for was it was more human friendly for certain people, right?
Right.
And so now you can still have a human friendliness. And now you also have you can have the AI figure this out for you.
Correct.
Right? You open up more access to all this SQL stuff, just like with coding and things, because you have a little AI friend to help you out.
Correct. Because if you look at the pipeline from the idea to getting back the exact data you want, sure, once you crafted the perfect SQL, you're going to get exactly what you want. But there was a gap. How do I get from the human mind to the perfect SQL? And sometimes that just wasn't getting solved efficiently, right? The exact 3,000 line SQL will give you the lowest cost, fastest access data, but there's no human that could write that 3,000 lines. Well, then you go.
Right.
Then it just doesn't work. But if the AI is so versed at coding and can help you generate that, and then from there, once the query is done, then the fastest way to get from query to physical data on the blocks on the disk becomes the fastest. So now the whole pathway from idea to result is closed.
Well, we after in all of that, we never actually introduced you. At the end here, you want to introduce yourself, and then as part of that, right? I'll put a link to the article. People can click on it and check it out. But also what are some other things that they can look into to kind of follow up on this if they're interested in more?
Yeah. So I'm Ivan Novick. I'm the group product manager for the data products in Tanzu. Tanzu is a Broadcom division. And so we work on a whole spectrum of databases and an integrated data platform for helping store, analyze, manage, decision support data, and also build new modern applications and AI applications on data. I think the Tanzu platform and the Tanzu data intelligence solution that we're building helps enterprises to go from ideas to business outcomes, as we've been discussing. And so I think have a look at the Tanzu website and collateral there, and then you can see a lot of stuff we're working on, and also reach out to us through LinkedIn or other social media to check out what we're posting about.
You know, what I always try to tell people about the entire, we don't say suite, but I'll say it here for fun, the entire Tanzu suite,
Yeah.
the box of, the closet of solutions is, there's always a pretty good chance that you already have access to it if you're in a large organization,
Yeah.
that it's available there. So like if it seems interesting, it's always worth just asking around and seeing if it's there already. And with that, we'll see everyone next time.
Cool. Thanks, everybody.